Hello, everybody. I'm Federica Ciuffo. I'm a specialist solutions architect at Amazon Web Services. I specialize in containers technologies. And today, here, I have Marco with me. He is a DevOps engineer in Amazon Web Services. Also, he too specializes in containers. And today, we are going to talk about multi-cluster. So just a quick survey. How many of you run or have run multi-cluster? OK. Many of you. Perfect, perfect. So today, we will be talking about multi-cluster from the networking point of view. So we want to understand which are the challenges and which are the solutions that are proposed in the Kubernetes ecosystem to overcome this, well, not so easy task. In fact, when you have two services that you want to connect, let's say that we have these services in cluster 1 and cluster 2, and we want to make the application in cluster 1 talk with the application in cluster 2, well, that's pretty easy. We use an ingress, and the deed is done. But what about if we have to connect these different services, different clusters, and have multiple services that need to be shared from cluster 1 to cluster 2? That's a little bit more difficult. So there are some considerations and challenges that come around. First of all, how do we connect these two clusters together, networking-wise, at the application layer? And second of all, how do we synchronize the deployment of our applications in cluster 1 and cluster 2? And on that point, our colleagues, Sahi and Dima, had a talk this morning. So you might want to go back and see that one on how to automatically deploy across clusters workloads. But well, back to networking. There are other challenges when you want to have this kind of architecture that have different microservices in different clusters that need to talk with each other, and you want to scale. You need to make a lot of considerations when it comes to security, like, for example, firewalling, etc. How to scale these not only in two clusters, but in multiple clusters, And another challenge that is a very big challenge when you think about multi-cluster is location-aware routing. So since KubeFed retired, there has been some projects to target this question, how do we connect different clusters and how do we do multi-cluster? So for example, you can see some of them in slides in here, but there are always some limitations to these kind of projects. For example, take the first one, Cilium Mesh. Great, but you are tied to a choice of CNI, Cilium. Also, I talked about location-aware routing before. If you're using Submariner, you can do that, but still it has limited support for this kind of advanced configurations. And in general, these projects, they work well, although they have limited support and limited documentation, as they are pretty niche. Another solution, most commonly known, is service mesh. In here, I will be showing some architectural diagrams. Those are from Istio, simply because it's one of the most commonly used service meshes in open source community. But well, what I'm saying today can be, up to some extent, generalized to other service meshes as well. So stick with me. When you want to start with a service mesh, well, you start with a single network, maybe. And this is the easiest way to implement a service mesh across different clusters. Very well. What happens if you have overlapping CIDR blocks, overlapping CIDR space? You cannot do a single network anymore. You need to rely on some kind of gateway, like on the right of this slide, so a multi-network approach. And this adds another layer of complexity. Again, if you have different clusters, in particular 2 or more clusters that needs to be connected together through the service mesh, well, the most recommended architectural pattern is to have a shared control plane. This means you need another cluster to deploy the control plane on. This means, again, other things that you need to take into consideration. Networking-wise, Okay, that can be done. But what about security? What about the encryption boundaries of your clusters? In fact, if you have a shared control plane, you're basically sharing the TLS certificate across multiple clusters. This means that, well, this could be okay for the most of the cases, but it could be not your case. You might want to have encryption boundaries across clusters, across set of applications, etc. This is another thing that you need to take into consideration. In general, so service meshes are great, have a lot of customizations, give you a lot of options when it comes to networking, advanced networking and security. But you can see here, those are maybe the easiest architectural diagrams that I could see and find in ISO documentation, and are not so simple. Adding to that, you need also to think about not only security for, I don't know, TLS encryption, but also security on how do I integrate RBAC, for example, with my service mesh. And in general, again, coming back to location-aware routing, how do I do that? You can do that, obviously, but there is a lot of customizations that you need to put on top and a lot of things that you need to manage to configure these things. So, how can we more easily connect different clusters together, share services that can be consumed independently on which clusters they are hosted on? Well, the SIG multi-cluster has created a set of APIs that are very well used in this space, which are the multi-cluster services APIs. Basically, the service export and service import that you see in slide, they enable you to first export your service, local service, to the underlying infrastructure, and then import your service from the underlying infrastructure to the second cluster. That way, by leveraging the multi-cluster services, you can have this kind of shareability and discoverability across the different clusters. You then will have also an MCS, multi-cluster service controller, that will do actually this kind of translation across Kubernetes objects and infrastructure. And this is usually used, well, in many different ways, but what we are seeing here in the Kubernetes ecosystem is very well used with the Kubernetes Gateway API. For those who don't know what the Kubernetes Gateway API is, it's basically another project from the SIG network that basically aims to standardize the Kubernetes networking and to take all the lessons learned from, well, what do you need and what do you want from service meshes, and what is lacking in the Kubernetes networking right now. For example, with ingresses. With ingresses, if you want to do advanced configurations, you actually need to rely on CRDs and annotations, which depend heavily on the choice of implementation that you are actually implementing to your clusters. So each time could be different. Kubernetes network wanted to standardize it and give you all these capabilities that you need. So basically, create this new set of APIs, which are they are new, but already very well introduced into the Kubernetes ecosystem. And another cool thing about the Kubernetes Gateway API is that it is role-oriented within your organization. So organizational roles in your organization will own an object from the Kubernetes Gateway API. The first thing that you want to create in your cluster when you want to use the Kubernetes Gateway API is the gateway class. The gateway class formalizes the set of load balancing implementation that you can use with the Kubernetes Gateway API, much like an ingress class for an ingress. Okay? Then the cluster operator will then create the gateway. The gateway is the point from where the traffic that goes from the outside the cluster is translated to in-cluster traffic. Could be a load balancer, could be a proxy. And then from the gateway, the traffic will flow according to some rules to your applications. This can be defined by the application owner in the HTTP route object. So in the HTTP route, you can see over there that is specified the gateway and then how the traffic flows and where the traffic is redirected to, the services. And here, the connection to what we said before with the multi-cluster services. So this service could be a local Kubernetes service, but it could also be an imported service. So you can use Kubernetes Gateway API effectively with multi-cluster services to achieve a multi-cluster. And Kubernetes Gateway API, again, also works with a controller. Like for the ingress, you had the ingress class, the ingress, and an ingress controller. The same is here. You had a gateway class, a gateway, and a gateway controller. And you see on the right that there are a lot of implementations already. You can see, I don't know if you are able to see that, but there are some pretty big names here, like Nginx, Cilium, Istio, Kong, etc. So there are a lot of implementations already. The nice thing is that whereas with the ingress, this implementation added a lot of CRDs, which were customized to the implementation, or annotation which are customized to the implementation, the choice of implementation that you had in your cluster. With this, you are basically relying on Kubernetes native API also for advanced configuration, so not CRDs which are customized or annotation which are customized. That's the main difference. And well, in Amazon Web Services, we are from Amazon Web Services, we will have a demo, so we want to introduce it really quick. We do use Kubernetes Gateway API and multi-cluster services with a controller that is AWS Gateway API controller. This is both an MCS controller, multi-cluster service controller, and Kubernetes Gateway API controller that translates the Kubernetes objects into actual Amazon infrastructure. As infrastructure, you can see on the bottom of the slide, we use Amazon VPC Lattice. Real quick, we don't want to explain too much of how Amazon VPC Lattice works, but real quick, what is Amazon VPC Lattice? Is a service that adds layer 7 capabilities, application capabilities, on top of Amazon VPC. Amazon VPC is basically a chunk of the AWS private network that we give to you and our customers, and that you own. So we added these layer 7 capabilities embedded into Amazon VPC to give you the possibility to connect automatically application across VPCs, across accounts, across different areas of your cloud. That means how this is different from the traditional networking model. If you had a traditional networking model, you had your application in two different clusters hosted in two different VPCs, then you needed to connect these VPCs with layer 3 routing, like for those who know these services, peering, transit gateway, etc. And then on top of this, again, you needed a layer 7 connection. Could have been a service mesh. So a lot of work here. We identified that this work is something that not everybody might want to do it. So we created this service to take and do this heavy lifting for you. That's why you basically need to define which applications you want to send traffic to, how do you want to send traffic to these applications, and which consumers you want to define for these applications, and some other things. Don't want to go into details. But we will be seeing this also with Marco next into the demo, so that's why I introduced that. Also, in here, there is a QR code for the controller that we built. This is actually in the launch blog, but we have in that the related repo. So you can go there. There are a lot of examples in the repo if you want to play around a little bit with this controller. And again, this is both the MCS controller and Kubernetes Gateway API controller that we built that does the translation from Kubernetes objects to actual infrastructure. And now I think it's time for the demo. Marco.
Can you hear me? Yeah, thank you, Federica. So, live demo on stage with 30-something degree. Yeah. So for the demo, we created an application. It's a very simple application. We have a front end and a back end. The front end basically is exposing an application to the internet and is calling an API provided by the back end. The back end is simply doing some math and talking with the database to provide these API responses. For the sake of this example, we are pretending that for some reason the backend is not working. Now, in those situations, normally, if the backend is not working, maybe it's a simple things you can redeploy. But let's assume it's something maybe that takes a little bit more to solve, and therefore you need to find a solution. And maybe you have the same version of the backend deployed across another cluster. So we want to point out a couple of things because we wanted to do this demo. To show that, one, we are in the worst possible scenario because both the clusters are sharing the same CIDR, and also all the clusters are in different VPCs. So you will see that there is a cluster 1 in VPC 1 and a cluster 2 in VPC 2. This is not only to simulate the fault, but also to let you picture maybe some other scenario like a migration. Maybe you are migrating your applications and you are not able to migrate them in a single go, and therefore you have a set of applications in cluster 1, you start to migrate them. Could be on-prem to the cloud, or could be cloud to the cloud. Maybe you are migrating just to another cluster and you have a number of microservices, and it's very difficult to deploy all of them all at the same time. And we have a demo. Let me show you the setup first, and then we will get to it. Let me know as well if it's big enough. We tried to make it as big as possible. What I have is 2 pods running. I'm on cluster 1, so in my original cluster, backend and front end. Both of those are exposed to a service. And as well, I have some CRD deployed. And if you actually look at the CRDs, are the exact same that Federica was showing in the slide. So I have service export, service import, and the gateway CRDs. Now, to generate a little bit of traffic, I need some help from you. So let me go back to the demo. If you please can scan this and open the application, or if the QR code is not working, should be the tiny URL. I will give you guys 1 minute. And surprise, surprise, being a presentation with 2 Italians is about pizza. So let me show you on the browser. It should work on the phone as well, but I will show you on the browser just to be sure. This is the application. You're asked to vote either pineapple or no pineapple on the pizza. There is only one right choice. But yeah, when you vote, what happens is basically that the front end is calling the back end, is making an API call. There are just 3 or 4 paths defined. And one of the paths is yes, increment 1 counter, or the other path increment the other counter. Now, I will give you guys some time to vote. In the meantime, I will show you if it's big enough. I hope so. The configuration. This is the front end at the moment. We're running some Python application that is just rendering some HTML file, but the important bit is this. So we're making this call to the backend using the service in the same cluster. So at the moment, cluster 1 has a front end that is calling the backend in cluster 1 that then is talking with the database and replying basically with the counters and things like that. Another thing to notice is that in parallel, because the good thing of this is that we can do it completely in parallel, we have some files that will define our configuration in Lattice. I will start with the gateway. You can think about the gateway, as Federica was mentioning, as the entry point for the traffic in your cluster. And as well, I have an export. So this is in cluster 2. Cluster 2, I'm exposing this service, which is an exact copy of my backend, simply deployed to cluster 2. And in cluster 1, so my main cluster, I have the import that is importing the same service and also has a couple of information about the cluster sets and the port 80, because all the services are exposed with port 80. Now, if I want to simulate, I will go the hard way and I will just delete the backend on cluster 1. So we can probably refresh the app and see that it's not working properly. But before doing so, here on the right, I will run the logs of the controller. I can show you cluster is pretty much empty, but we have this namespace configured, which is the namespace that the controller uses. If I get the pod of this namespace, you will see that there are the two controllers of Amazon VPC Lattice. One is the primary, one is the secondary. I will just run the log. And send. Okay. Okay, thanks. Okay, I will make a bit of space so we understand when new logs are coming in. What I will do now is delete completely the backend deployment from cluster 1. Kubernetes backend. And now if I go back to my application, the front end will be running anyway because there are two different pods. So if you give it a little bit of time to run, the front end will work. But if I click on it, the moment I call the backend, you will see that it's throwing an error because it's not able to talk with the backend service local. Now, as I was mentioning, I have this model deployed. So I have this route, is an HTTP route that basically instructs through the gateway API Lattice how to handle traffic. And I have the HTTP route configured to send 100% of the traffic to my cluster 2. How can I use this? Let me show you actually the console and how Lattice works on the backend. If I go to VPC and I show the services, you will see that I have a service configured. This service is pretty much an abstraction of a load balancer. I'm oversimplifying it a little bit. But you can see that if I go to services, I will have an entry point and some condition based on the path. As I was showing, this is a one-to-one matching. I'm sending 0% of the traffic to the service on cluster 1, and I'm sending 100% of the traffic on the service on cluster 2. How can I leverage this? Basically, Lattice creates an URL that resolve to Amazon specific address. So if I take this URL and I change the front end is expecting basically a backend as environment variable. I can put the Lattice URL and I can redeploy the front end. Kubernetes front end. And now, if you give it 1 second, you will see that the application is working again. So let me go back to it. And I can go back and refresh it. And now, when I hit the application, it's working again. So I'm talking with the backend. The difference now is that I'm talking through the Lattice network. So just to show you, the backend is missing from cluster 1, but I'm still able to use the application because I'm talking with cluster 2. Now, a couple of things about this. One, the beauty of this is that if I go to the Lattice console and I show you the route, both of them at the moment are talking and are pointing to Kubernetes service, but this can be a Lambda function, serverless, or an EC2 instance, or a mix of those. So if you are migrating, for example, from Kubernetes to serverless, it's very easy to define some paths and route traffic gradually to your serverless application. Same thing if you're migrating from serverless to container or to EC2 to container. Anything you can think about can be done with different paths. You can do V1 or V2, or you can do percentage of the traffic. If you want to do proper multi-cluster, you can do something like this. So let me redeploy the backend under Kubernetes. This will redeploy the backend, you can see that the logs on the right lattice is picking up. So in a couple of seconds, we'll converge, and we'll understand basically that the backend changed. And if I go to my route, I can configure the route basically to do 50-50 or 10-50. You can do canary, you can do blue-green. But if I say this and basically reapply the route, yeah, you will see that lattice will try to converge. It's going to take a couple of seconds. But if I go back to the console and I refresh this, you'll see that 50% of traffic goes to the front end and 50% of the back end. Just to show you I'm not lying, Lattice comes with integrated monitoring and logging. So I have some logging configured for this service. And it's going to take a little bit, sorry. But I can see pretty much the API call coming from you guys. And you will see that what we are doing behind the scene is basically calling the API with a /no path or /yes path. The application is really easy, but there is the actual traffic flowing through Lattice. And to go back to the slide for a second, sorry, this one. I just want to summarize what we did. Basically, we removed the backend from cluster 1, and through the Kubernetes Gateway API and through Amazon VPC Lattice, without configuring layer 3 connectivity, without ingress, without resources, we were able basically to talk with the backend in a completely different cluster. And again, we wanted the worst case scenario, so overlapping insiders, different VPCs, same name of services on one side or the other, same namespace, really worst case scenario. And that's pretty much it. Before concluding, I want to show you one last thing, just to check if you guys are on the right side or not. There should be the results of the survey. And we can see that, well, most of you has no pineapple and other has pineapple. So no pineapple wins, thanks. And let me go back to the slide. This is the link of the survey. It is really, really important for us, even if you leave like a quick comment, it will help us to understand where are the gaps and where we need to improve for the next talk. Also, if you want to know more about Lattice, there will be probably a copy of the presentation up. We have QR code, we have links to documentation and everything. That's pretty much it. Federica, back to you. In case there are questions or anything specific to AWS, we are happy to answer. Or if there is no time, we will be around after the presentation.
Thank you for this talk. Actually, we have 4 questions, and we have plenty of time. So it's very cool. So the first one is this one over there. Is there a way to define a specific health check which is used for this specific backend endpoint?
It is, yeah, I can show it probably on the console if we have time. How many minutes we have? Yeah, plenty.
It's not.
The way Lattice works is... Oh, okay.
There we go.
Yeah, cool.
There we go. Go ahead. Go ahead.
See, no, it's still showing the presentation. So can you put back? Anyway, the long story short. Yes, you can. However, Lattice is expecting a very defined list of HTTP response code. So if your application is applying 200 to the path you specify for the health check, probably it's fine. If you have some custom code, for example, this application is really weird because it replies a 404 when it's working. It's a bit a long story, but you can define code that Lattice should expect for the health check. And then when the health check is completed, there are some defaults that is probably 5 retries in 30 seconds. The application is marked as healthy.
Nice. OK. The next one, can the Kubernetes Gateway API work with gRPC as well as HTTP requests?
Federica?
Yeah, it can work with the layer 7 traffic. Also, VPC Lattice takes gRCP. So if you're thinking about implementing this in AWS, that's a yes. We do support that as well, with this integration that we just explained, basically.
Great. next one. How do you model and enforce access control on the network level?
Yeah. With the implementation that I explained, because there are many other different implementations, I'm not going to talk about other cloud providers, etc. But with this implementation, basically, you have a lot of components of VPC Lattice that I didn't explain today. But there is a thing that is called basically service network that enables you to group together and a set of applications and that have common access patterns and community and security needs, basically. So this abstract thing is a new networking boundary, different from the networking boundary that you have think about like VPC and things like this. Service network is called. So basically, this is a first approach on how to grant the access to your backend services to only what you need, like zero trust approach. And then on top of that, at the service network level and at the service level, which was the thing that Marco was showing you before in console, you can also integrate identity and access management at both layers for authentication, authorization, and then for authentication, we do support as well AuthZ with Amazon VPC Lattice and this configuration that we showed you.
Thank you. When would you use this instead of using an ingress with ELB communication and target groups?
I can take this. I mean, there is no yes or no answer here. It really depends on your configuration. But in the example that we ran, we are using, for example, overlapping CIDRs. And we were using different VPCs. So although this is possible, we are talking about the more efficient way to do it. As for everything with container, there are probably 3-4 solutions to the same problem. But we wanted to show something that is driven by a set of APIs that are fixed for all the products, and 2 is easier-ish to implement respect to other solutions. And also, you don't need to set up layer 3 connectivity, which is a huge plus, depending on your setup.
Got it. I'm not sure if you already answered this one during your talk, but the question is, can you use MTLS with this approach between services across clusters?
Again, it's a yes and no question. It's very difficult to answer this, but whoever asked this question, there are our LinkedIn URLs into the presentation. If you get in touch, we can have a discussion, because it's going to be really difficult for me to answer in 30 seconds. It's a bit of a complicated topic.
No worries. 2 last questions. Is there any type of region limitation for AWS Lattice? Thought is it is feasible solution to a disaster recovery scenarios?
Yeah, I'll take this one. So VPC Lattice is a regional service, so it operates in the region. Although we do have solutions like AWS solutions that can implement this kind of, let's say, cross-region connectivity across different VPC Lattice service networks. So not out of the box, like 0 things that you need to configure, but it can be used to have this kind of cross-region implementation as well. Not out of the box, though.
As we have a little more time, I've added 1 last question. So 2 last. Does Lattice work cross-account even without IAM identity provider?
Yeah, that's the beauty of it. Basically, there is no transit gateway or connectivity required. Lattice is a full managed service that will provide connectivity from VPC to VPC. Mm-hmm. And is managed. We are using it with containers here, but it's an AWS service that can be used, as I mentioned, with the EC2 and serverless, and also is 100% covered by the SDK. So if you don't want to use container, but you want to join to Lambda function for some reason, you can do it through Lattice.
Cool. And the last one, or perhaps if there's anyone more questions in the audience, but is it possible to use service mesh capabilities in this approach?
Is the question, does VPC Lattice have service mesh-like capabilities, or can we use it together? Because it has some kind of service mesh-like capabilities. The answer is yes. Works at layer 7, and so it has this set of features that we see that are most commonly used by our customers with service mesh. The other thing that I was saying, can this be used in conjunction with a service mesh? The answer is also yes, because basically the beauty of it is that we are giving you an additional endpoint that doesn't collide with the the previous endpoints that you use. Like Marco showed it within the cluster with a local service he was using, and then he changed it with another endpoint that was already there, basically, by VPC Lattice. So also with service meshes, you can use them together, you can migrate or whatever. So the two approaches can be used either together or gradually move to one or the other. So yeah.
Awesome. I think that's it. Is there any one last question in the audience? Someone just raise your hand. 1, 2, 3. No one. Thank you very much for the talk.